Modern Technologies in Food Preservation, Part 2. Dear students, in this chapter on control of microorganisms in foods, Part 2 includes the modern methods of food preservation used in industrial sectors. Introduction. Many of the technologies that can work at home and cottage technology cannot be used at large scale operations. Hence, technologies which can be used as a continuous process were developed. The major technologies that are employed to preserve the quality and microbiological safety of food at industrial scales can be broadly classified into three categories: method to preserve the access of microorganisms to foods, methods to inactivate the microbes which have gained access, methods to prevent or slow down the growth of spoilage organisms if ever they are present in food and have not been inactivated. Currently used traditional preservation procedures has dealt in the control of microorganisms in food part 1 are also a part of these categories. However, industries are looking for better and cost efficient methods of food preservation. Most of these modern methods may be the modification of the existing methods. These modifications have improved the quality of the food products without the use of extreme or a single technology. Many food microbiologists have realized that improved hygiene and the application of hazard analysis and critical control point called as HACCP techniques help to improve food quality. A major reduction in the contaminating organisms will also be achieved if new technologies which can efficiently control the foodborne organisms are employed. It is achieved by not allowing the organism of concern to enter the food industry or the catering establishments. Such a method would take care of some of the momentary losses of hygiene that occur. However, any major method to slow down or prevent the growth of microorganisms in food have to be achieved. New methods need to be designed. These methods can thus be a part of the use of combined technology or combined preservation techniques. These technologies are discussed under the following titles: 1. Hurdle technology, 2. Irradiation, 3. Microwave processing, 4. Non-thermal method of food preservation. Hurdle technology. The hurdle technology is in controlling of microorganisms for the preservation of foods. These methods in a stable product controls microbial spoilage and food poisoning. They can also help in accelerating or limiting the desired fermentation process. The microorganisms present at the start in a food product should not only be able to overcome, that is, jump over the hurdles present, otherwise the food may spoil or even cause food poisoning. When multiple methods are introduced in smaller doses so as to preserve the sensory and the nutritional quality of food, the microorganisms present cannot overcome these hurdles, and thus the food becomes microbiologically stable and safe. Examples of hurdle technology: fermented foods. In fermented foods, a sequence of hurdles lead to the stable and safe products. Fermented foods like sausages, hams, ripened cheese and Indian foods like dosa, dokla, etc. are such technologies which are naturally adapted. The desired competitive flora like lactic acid bacteria are naturally adapted and overtake the food poisoning and thus the spoilage organisms. Hurdle in the beginning of the fermentation of salami and sausages are nitrites and salts, which inhibit many of the bacteria. However, lab which naturally are resistant to these hurdles are able to grow and multiply. They also utilize the oxygen and thus cause a reduction in the redox potential of the product. This in turn enhances the EH hurdle, which inhibits the aerobic organisms. The lab in turn grows by metabolizing the sugars present in the food. Lab during its growth produces organic acids like lactic and acetic acid. Further, the acid produced decreases the pH of the product. The acidic pH of the product is thus the next hurdle created for the spoilage organism. Hence, it would be difficult to cross such multiple hurdles by the spoilage organisms. Shelf stable products or SSP. Products which are heated to a certain temperature with high moisture on the principles of hurdle technology and stored without refrigeration are called as shelf stable products or abbreviated as SSP. These products offer advantages like mild heat treatment, that is between 70 to 110 degrees Celsius, no requirement of costly refrigeration distribution systems, which in turn saves energy during storage. Due to the medium temperature of heating, it improves the sensory and the nutritional property of the food. SSPs are heated in sealed containers like casings, pouches or cans, which avoid recontamination. However, because of the mild heat treatment, these foods still contain viable spores of bacilli or clostridia, which are inhibited by the adjustment of water activity or AW, pH, EH and low quantities of preservatives, which cause sublethal injury to the spores. Intermediate moisture food or IMF. Intermediate moisture foods IMF are in the water activity or AW range of 0.90 to 0.60. Such foods are stabilized by the introduction of additional hurdles like heating, preservatives, pH and EH. These foods are easy to prepare and are stored without refrigeration. Transportation and marketing of such foods are cost and energy efficient. Traditional IMF based on meat, fish, fruits and vegetables are common and much liked in different parts of the world. This is mainly because they are tasty, nutritious and safe. Due to the requirement of high temperature, cooking IMF have its own disadvantages like poor palatability and the need to introduce often high amounts of antimicrobial additives. Multi-target preservation of foods. A synergistic effect is something that every food technologist would dream could become true. Can we introduce multiple hurdles at the same time during the processing of food? Different targets like cell membrane, DNA, enzyme system of the spoilage organism along with the disturbance of pH, AW, EH within the microbial cell disturbs the homeostasis of the microorganism. In practical terms, this could mean that it is more effective to use different preservatives in small amounts in a food than only one preservative in large amounts. Such treatment might hit different targets within the bacterial cell and act synergistically. Appropriate water activity management by the addition of salt and fat could become the promising area of research in future. A few such hurdles are listed in Table 1. Food irradiation. After more than 5 decades of research and development to prove the safety and wholesomeness of the food, irradiation was accepted. This method of food preservation had the largest political debate and public scrutiny. Food irradiation today is established as a safe and effective method of food processing and preservation. Similar to other food preservation methods, food irradiation offers advantages and disadvantages relative to the type of food to be treated. Its role as a method to ensure hygienic quality of the more solid foods like meat, poultry, seafood has increased its use in many countries. The Joint Committee of Experts from FAO and WHO along with international agencies for atomic energy worked on the wholesomeness of irradiated food. This committee is abbreviated as JECFI. The committee has been working from 1960 and is convened from time to time to study the safety of food subjected to ionizing radiation treatment under properly controlled conditions. The Codex standard and its associated code of practice provide important practices for proper irradiation of food, and this can be up to an overall average dose of 10 kilogauss, and essential control procedures. The Codex standard was recommended by the CAC to all the member countries and was accepted in 1984. A few countries are yet to accept the same. This is mainly due to the lack of facilities for large scale irradiation and further testing of these irradiated foods. Advantages of food irradiation. Irradiation is proposed as an alternative to fumigation of food. Fumigation of food and food ingredients are commonly practiced. Fumigants like ethylene dibromide (EDB), methylene bromide (MB), and ethylene oxide (ETO) has been either prohibited or is being increasingly restricted in most advanced countries. Their residues are considered to be deleterious to health, environmental, or has occupational safety concerns. Irradiation has been demonstrated as an effective alternative to fumigant mentioned above. Low doses of irradiation between 0.2 to 0.7 kilogauss can control insect infestation of grain and other stored products. Unlike fumigation, irradiation does not leave any residue in the products. Low dose of irradiation is effective in inactivating non-spore forming pathogenic bacteria and foodborne parasites. Irradiation can be used as an economical treatment for commodities such as cocoa bean, potatoes, onions, yam, and garlic to control sprouting. Mushrooms and asparagus are irradiated to control a rapid physiological change leading to spoilage. Limitations of food irradiation. Irradiation can either replace good manufacturing practice nor it is applicable to all food. For example, dairy products such as milk and butter can develop an off odor when treated by irradiation. Microbial toxins such as staphylococcal enterotoxin and aflatoxin produced by aspergillus cannot be easily be inactivated by irradiation. Virus also cannot be easily be destroyed by low dose of irradiation. As this technology can handle large quantity of products, a factory using irradiation must be located at a central point. Sufficient amount of food are to be produced and transported to the plant for treatment and storage before sending it to the market. Irradiation has a low operational cost, especially with regards to energy requirement. However, irradiation has a high capital cost and requires a critical minimum capacity and product volume for economic operations. As food irradiation is perceived to be associated with nuclear technology, irradiated food can be erroneously connected with radioactive materials. Thus, the introduction of food irradiation on commercial scale requires an educational campaign. The number of countries which use irradiation for processing food for commercial purpose has increased steadily. Spices and vegetable seasonings are the most common products which have been irradiated in about 20 countries. Since 1990, when the European Union proposed to ban on the use of ethylene oxide for fumigating food and food ingredients, the use of irradiation to ensure hygienic quality of spices and vegetable seasoning has increased significantly. Microwave processing. In the wider field of preservation, microwaves have been used in drying, blanching, and vacuum drying. Microwaves in combination with hot air has been shown to have positive route to drying of foodstuffs. The principle behind the potential of microwaves to enhance heating rates is simple. Microwaves cover the broad range of radio frequency from 300 megahertz, that is million cycles per second, to 300 gigahertz or billion cycles per second. This corresponds to wavelength between 1 meter and 1 millimeter according to the equation wavelength in centimeter is equal to speed of light in centimeters divided by frequency in hertz. Microwaves are reflected by metals, transmitted by electrically neutral materials such as glass, most plastics, ceramics and paper, and absorbed by electrically charged materials. Microwave penetrates deeply into food material, and as they penetrate, the energy they carry is converted to heat, actually by the food material itself, mainly by the mechanism of polar and ionic orientation. The aim of using microwave processing in preservation is to deliver a more homogeneous heat treatment at a faster rate than conventional heating. In general, and pasteurization or sterilization in particular, such fast flow of heat is an added advantage as the time of heating can be brought down. The major benefit of microwave processing is it can replace the need of water or steam as a heating source. Therefore, it is possible to manufacture continuously rather than batch wise. As this form of heating occurs within the material, the limitations of surface heating are reduced and the process can be greatly accelerated. This is particularly true for materials with a low thermal conductivity and for drying process where the high dielectric loss properties of water result in selective heating of moist areas and rapid diffusion of food vapors to the surface. Energy is not used in heating of the wall of the apparatus or the environment. Energy is developed where it is needed, that is, in the material being processed. In drying processes, microwave energy is applied as a conventional drying process at a cheaper cost. Heating adjustments can be made online with a precise control. Hydrostatic pressure technology is a non-thermal food processing technology whereby foods are subjected to high hydrostatic pressure between 100 to 600 millipascals at normal ambient temperature. Since HHP denatures the protein and polysaccharide, the technology also presents interesting application in the area of food texturization. However, this may also change the taste and texture of the food. This sometimes may not be acceptable to the consumers. At present, no commercial HHP processed foods are produced. Modified atmospheric packaging or MAP. The replacement of air in a packed food by a different mixture of gas is known as MAP. The proportion of each gas is fixed when the mixture is introduced during food packing. The ability to modify atmosphere packaging to extend the shelf life of food has been recognized for many years. There are several techniques by which the atmosphere surrounding a product can be modified. Controlled atmospheric packaging or CAP. CAP is a condition in which the composition of gases in the pack is continuously controlled throughout the storage. This technique is used primarily for the bulk storage of products and requires constant monitoring and control of gas composition. Equilibrium modified atmosphere or EMA. The pack is flushed with the required gas mixture and the product is sealed with a modification of the atmosphere. The respiration of the product and the gas permeability of the packaging material allows an EMA to be reached. It is mainly used for fruits and vegetables. Vacuum packing or VP. The air is evacuated and the package is sealed. During storage, from metabolism of the product or microorganism, the gas produced changes and therefore, the atmosphere becomes modified indirectly. The advantages and disadvantages of MAP is listed in table 2. aseptic processing. Aseptic transfer of sterilized materials into sterile container is a common method of pure culture management. Food which is sterile, example coconut water or tender coconut, is subjected to filling into a decontaminated container within an aseptic filling zone. However, all food contact surfaces should be sterilized before the production starts and have to be maintained in the same condition. The major limitation of this technology is that only those food which are in sterile condition in nature can be packed using this technology. Microbial decontamination by organic acids. A number of products are traditionally preserved using organic acids. Example, fish preserved using Garcinia extract. The antimicrobial effect of organic acid have been known since time immemorial. For example, bacteria converts lactose into lactic acid, and the lactic acid has been used from a long time to change the flavors, composition and consistency. This was used in softening of meat and its texture improvement. Now, these acids are synthetically produced and are used in food preservation. Both acetic and lactic acid used individually or in combination enhances the antimicrobial effects. A large number of foods are pickled using these acids, example gherkins, vegetable pickles, etc. Organic acid behave as preservatives, changing the microenvironment into an acidic environment and also by acting on the cell membrane of the spoilage organisms. Conclusions. Food irradiation is becoming a major technology in feeding the world's increasing population. This method is used to maintain the food of animal origin, spices, grains and other stored products from insect infestation and microbial spoilage. It is an energy saving method to maintain food quality. Microwave processing in the preservation area is fast becoming accepted. Further, advances need to be brought in before this method is widely accepted. The use of organic acid as decontaminating agent is not ideally used for all foods. Product packaged in MAP is now a common package in the market. This is mainly due to the development of intelligent packing and materials available today. A combination of these techniques through the method of hurdle technology is the most practiced method of food preservation today.